Today we're continuing in chapter 7 of, this is book 2, isn't it? Shouldn't say CC3, should it? Let's fix that. On percent increase and percent decrease. So we start off with this problem with page. I won't read it to you because you're already supposed to have done this. So the line diagram might look something like this. So 100% is $50. We know that. And there's a special price where it's only $34. That's one part. And what we want to know is the percent of the cost of the class she would save. So do we want the percent that goes with 34 or subtracting? We can get that that's 16. So that should be something you have on your diagram. Which part do we want to know? The percent that goes with $34 or the percent that goes with $16? Anybody? The 16. This is what we want to know. Okay. So then it says, write an equation and calculate the percent of the cost of the class she would save. So this is part of why I like line diagrams, because if you have one drawn correctly, the equation is right there staring you in the face. 16 over x equals 50 over 100. Whenever possible, I reduce before I start doing anything else. So that's 16 over x is equal to 1 over 2. There are all kinds of things that we could do for this. Probably most of you would just cross multiply at this point, yes? So that would be x is 32. So it's 32%. Does anyone have any questions about that problem? All right, gave you that one sort of as a warm-up to something that's a little bit different. So Joe's Lawn Care is increasing their rates from $12.50 per hour to $15 per hour due to rising fuel and labor costs. Joe is concerned because his financial partner told him that raising rates by 33% at one time will cause him to lose a lot of business. Should he be worried? All right, we're going to make a line diagram, and then we're going to write and solve an equation. So here's the deal. 100% is what he's currently charging. He's charging that much. And then we're going to go up to $15 an hour. So we can figure how much did he go up by per hour? $2.50, yeah. And we'd like to know, well, what percentage is that? So again, the equation is right there for you. 1250 over 100 is equal to 2.50 over x. Now, there are all kinds of different ways that we could deal with this. If you want to cross multiply, that's fine. Let's do it that way. This would be 12.5x. Do we really need the 0 after the 5? Only when it's actually reporting the money. So it's 12.5x is equal to 250. So I can do that division. 12.5 divided into 250. I have to move the decimal one place. See, 125 into 250 is 2. Exactly. That's nice. Bring down the 0. That's going to go in 0 times. So x is equal to 20. So should he be worried? No. How much did he raise his rates? He raised his rates 20%. Okay, now, there are other ways to set this up and other ways to do these problems. Again, I'll tell you that if you talk to a parent or to a tutor or anything like that, they're likely to show you some other way. The only problem with that is that you have to always be thinking about, all right, in this particular case, I have to set it up this way, and in this particular case, I have to set it up that way. If you'll draw a line diagram, it's already set up for you every single time, which is kind of why I like the line diagram thing. So let's read this together. The percent change is a comparison of the amount of change to the original number. If a number increases from the original amount, it's called a percent increase. If the number decreases from the original, it's called a percent decrease. So in the first problem, we found the percent decrease, and in problem 2, we found the percent increase. So let's take a look at this real quick. Got the same numbers, but we're going to have different results. What's the percent increase from $30 to $33? 10%. So, yep. But we're going to work it out real quick. From $30 is 100% to $33, the increase is $3. And this is a really easy one to solve. 30 over 100 is equal to 3 over x. What does 30 over 100 reduce to? 3/10. 3/10 equals 3 over something. What does the something have to be? It's got to be 10. That's a 10% increase. Now, you might think that if you decreased from $33 to $30, that would be a 10% decrease. You would be wrong. Let's take a look. Our original amount is $33. That's the 100%. We're decreasing it to $30, a decrease of $3, and I want to find this percent. This time I've got 3 over x is equal to 33 over 100. You could cross multiply and do this. Let's go ahead and do that. You're going to get 33x is equal to 300. So I'm going to divide both sides by 33. And I'm going to reduce that. It's 100 over 11. Because that's an easier division to do. So that goes 9 times, that's 99. Point, bring that down, that's going to be 0. Bring down another 0. That's going to be 9 again. This is going to keep going over and over again, isn't it? Because I've got 100 this time, and then I'm going to get 10 the next time, and then 100, and then 10. This is 9.09 repeating percent. And at first it feels surprising that those two numbers are different. Why are they different? Because what was 100% changed. From $30 to $33. All right, one more question. To attract new customers, a company called ShoeFit offers a 10% off coupon to all of their customers. Unbeknownst to the customers, however, they first raised the price on every item in the store by 10%. You would be surprised. There are actually companies that do stuff like this. They raise the price and then they tell you that you're getting a percent off. It happens all the time. Well, and there are ones, so you guys are probably too young. Bed Bath & Beyond. Bed Bath & Beyond has almost entirely gone to online stores now. But they used to have, regular stores, and once a month they sent out a coupon for like 30% off. Yeah. So my comment was, if you paid it full price for anything at that store, then you were an idiot. You were overpaying. Because they jacked the prices up because they knew everybody had a 30% off coupon. Okay? So,
save my 30% coupons out, and then I would do them both and be like, sucker.
one coupon per item is usually the rule. All right. So, will the price the customer pays be more or less than the original price is the question. Verify your answer by checking the price of a pair of shoes that was originally $46. What percent change is this from the original price? All right, so we're going to jack it up by 10%, and then we're going to take 10% off. It's not going to be the same amount, is it? So let's look at it. All right, so originally, 100% was $46. We're going to jack it up by 10%, right? I think that one's easy enough to do in your head. How much are we going to increase the price by? What's 10% of $46? Yeah, $4.60. So this new price will be $50.60. Now we're going to take that, and that's going to be my new 100%. And we're going to take 10% off. So you're only going to pay 90% of that. And we want to know not just how much was taken off, but what's the new price going to be? So X over 90 is equal to 50.6 over 100. So 100x equals, let's see, 50.6. I told you could use your calculators on that. Somebody have this already? Okay. So this is 45540 divided by 100. I've done something badly wrong, haven't I? I did what with the decimal?
Decimal.
So far I've heard 3 people say something, but I can't sort it out. What now?
When you multiply 50.6, you forgot to add the decimal to the addition number.
Oh. So this is going to be 4,554. Thank you, ma'am. So the new price is going to be $45.54. So they're going to pay more or less than the original price? Very slightly less. They have saved 46 cents.
So it's good old 46 cents. Yep.
Yeah.
Get you a piece of gum.
46 cents.
So if they raise the price by 10% and then lower it 10% from the new price, you are saving some money, just not very much.
A Tic Tac. You saved a Tic Tac, guys.
Any questions about that? Okay, please go ahead and get started on today's assignment.